All right, so thank you everyone for coming to our commercialization talks. We have Mr. Albert Mestre here today. We've got quite a few different variety of people as well, so I'll just give a quick intro on these talks. So the CARES Commercialization Talks were started by two of our research fellows here at CARES, and they thought it would be useful to have a space where researchers who are planning to commercialize their work could connect and learn more from one another. So Dr. Nicholas Jose and Dr. Zhen Guo have both successfully created their own startup companies in Singapore and the UK. If this is your first time attending a talk and you are unfamiliar with CARES, we are the University of Cambridge's research center here at the Create Tower in Singapore. We have been running since 2013, mainly doing work related to decarbonizing Singapore's chemical industry. So without further ado, it is my pleasure to introduce today's speaker, Mr. Albert Mestre, who is a chemical engineer turned CEO and co-founder of his own company. Albert saw huge potential in the worlds of AI and chemical engineering and decided to start Intemic upon realization there was no research group in Spain to develop this potential. Intemic is a no-code, cloud-based platform which combines process engineering with the latest AI techniques to build digital twins and democratize generative process design. I will hand this over to Albert now.
Perfect. Thank you, Olivia, for the introduction, and thank you to everyone who invited me in this presentation. So I will start to share my screen. Okay. Okay. So I will talk about 20 minutes or half an hour about this presentation. I think the questions are for the final of the presentation, but if someone wants to ask some questions or add some comments, for me it's okay. So I will talk a bit very shortly about myself, about the motivation nowadays for scientific entrepreneurship. I obviously we'll talk about what we are doing in Intemic, and I will also explain how to go from science to business and sell your idea and your products. So about me, this is Albert. I studied chemical engineering at Universitat Autónoma de Barcelona. Well, I'm from Barcelona in Spain. And I hated software. I did chemical engineering because I loved the maths and the chemistry, and I liked to touch things and do some real stuff. So the subjects in the university which were involved about software and programming, I didn't like that much. But then once I entered into a company, it was a chemical analysis company, I started working with data and with analyzing data, and I discovered machine learning. So I fell in love with this world, and that's the reason I pursued postgraduate in another university, Universitat Politècnica de Catalunya, about artificial intelligence with deep learning, which it was such a different world from chemical engineering. And this postgraduate was about image processing, natural language processing, all related to deep learning, programming in Python. And the people in this postgraduate was so diverse, were from mathematicians, people from telecommunications, medicine. It was so diverse. So I see a lot of potential of combining these new deep learning techniques with the traditional chemical engineering. And that's the main reason why I started a company called Intemic, mainly because I didn't found a cool research group in Spain that applied that both fields. So as I didn't found any research about this, I tried to create my own research, and it's what I will explain today. So I think nowadays is a very good time for scientific entrepreneurship, because we have a lot of problems in society which can be solved by deep technologies. And deep tech is a word which is now increasing its popularity. Also a lot of investors are looking into these deep tech solutions, and it can help a lot of companies and solve a lot of problems in a very systematic way. So deep tech can be implementations of artificial intelligence, blockchain, synthetic biology. I think all the technologies that combine very deep knowledge of core technologies can have a lot of impact in many fields. And I think one interesting field to work is in climate change, decarbonization, and sustainability, because there is a lot of work to do here. And we need a lot of deep tech applications in this field to evolve better as a society. So I focused my research into the chemical industry, which needs a complete transformation, since it's very traditional and boring. Actually, I say boring because I worked a bit as a chemical engineer in some big companies, and everything is already done. You cannot change anything. You cannot propose new methodologies. So that's why I say it's a very traditional industry. It's very low digitized, and it's the reason why it makes it very low transparent, and it's very unsustainable nowadays. We are getting carbon out of the ground, petroleum, to manufacture a lot of products that are disposed in the environment. And its chemical industry is one of the most polluting industries in the world. So it needs a complete reshape of this industry and implement new technologies for optimize and operate existing processes and digitize these processes to take traceability of the supply chain, information about the emissions, and a lot of knowledge about this complex industry. And also, we need to eliminate the use of fossil fuels like petroleum and primary raw materials. And this industry needs to implement secondary raw materials, waste, even CO2 as new raw materials for manufacturing products. And this is very complex. So this is why we need technologies here. This is why I explained. We take primary raw materials for the production, and not only is the global primary source of CO2, but also products are non-biodegradable and it becomes waste. So you already know that these are problems. It would be much better if we lived in a circular bio-based economy, which means that we use our waste to manufacture new products in a circular way and reusing them. So this would be very ideal, but we are not yet there. One of the reasons, because of costs. Customers, at the end of the day, they look for the economic. So if fossil-based products are cheaper than the green premium that is needed to be sustainable, it's very difficult to compete with this. So it's a matter of optimization and improving the efficiency of the new technologies to reduce this green premium and compete with petrochemicals and all this stuff. So this is one of the missions that we have in Intemic. We are quite a small group, well, a team, where we are 3 full-time people working in the project. We are chemical engineers and also software engineers. And we have also 2 advisors with a lot of experience in sustainability and life cycle analysis, and also in process engineering. So we are creating software products for 2 different customers. One, for creating digital twins of existing processes, and another platform for designing new biochemical process on an industrial scale. So we have 2 different platforms. And the first one, which is to create the digital twin of processes, we are working with Spanish companies to optimize their manufacturing line by using AI and analyzing their process data, and give recommendations, give predictions, and give the customer a lot of information, which helps them to reduce costs, optimize their line, and also reduce weight. So we basically take information from PLCs or manufacturing data. This is an example of some process data that we feed into our AI models to then generate predictions of some of the attributes of the product. In this case, Aircross is a chemical company from Spain which produces plastic, and they have some attributes of this final product which they have to measure to have in a range for quality standards, so they can sell to their customers. So this is very complex for them because it depends on a lot of variables and scenarios that depend on their production line. So it's like a big multi-variable problem. So AI is the perfect implementation for analyzing this data and performing predictions, so they can understand why this is happening in their process and optimize their production within the quality standards. And the second product we are working on, and this is the most deep tech implementation, is for designing new biochemical processes on an industrial scale. Most deep learning applications is for interpolation. This means that you have some data that you train models and everything, and you do predictions. So actually it's like the first plot I show, where you can see actual prediction, actual results, and prediction results. Actually, artificial intelligence is like a linear regression, but with a lot of variables. So we are taking this to a next step, which is learning from simulations to generate knowledge and make decisions. And this is a screenshot from DeepMind presentation that AI can be applied for scientific discovery and is already implemented for new drug discovery, protein folding, prediction of protein binding, and we are taking it to process engineering, which is a new approach. And this is an example of a game. I don't know if you are familiar with this, but AlphaGo is a game from a very origin game from from Asia, which has very difficult rules of the game. And DeepMind trained a reinforcement learning program that learns from the rules of the game, and it plays the game with very efficient performance. So why we think process engineering can be also solved by AI? One, it has a massive combinational search space. It means that if you want to manufacture, for example, new products from new feedstocks like CO2 or whatever, you have a lot of options. You can add many different equipment. You can obtain many different flow sheet configuration and parameters, and it has like a lot of variables to optimize. So it makes it very difficult for engineering companies. In the second hand, there is a clear objective function that it can be defined by the economics of the chemical process and the environmental impact. The economics, I mean the capex and the opex of the process, for example, which is the economic information of all the equipment and all the investment that it needs to be done. And in third place, we have accurate simulators. It can be process simulators like Aspen Plus, ProSim, or other simulators like the one we developed based on an open source project, which allows to train these AI models and learn by performing millions of simulations. So this, I think, this can have a lot of impact to explore within new organisms, new bioprocesses, and new concepts of biorefineries. This is an exemplar image of microalgae, which is now one of the topics of interest for building chemicals from our CO2 of our atmosphere. So biorefineries can be designed to capture this CO2 and make products for cosmetics or nutraceuticals or pharmaceuticals. And this is some of the research interesting for many companies. So the design of biorefineries is very complex because the current tools in the industry, like for example, Aspen Plus or Super Pro Designer, I don't know if you are familiar with that, but it's very complex. I mean, you have to be a super process engineer, super senior process engineer, to be able to put all the information in the software, perform calculations, perform the optimization, and download results. So this is one of the problems that we try to solve with our platform. And biorefinery designs can be like this. This is an example of complex biorefinery, which can have more than 100 streams. So it's very complex to optimize the overall biorefinery because all streams are connected within them, and it feels like a cubic Rubik cube for solving this and obtaining efficient production of your final product. The minimum waste amount, the minimum energy requirements. I mean, it's very complex. So why are we working with reinforcement learning in Intemic? We have a simulator based on an open source project called Biostim that was developed recently in the United States. And we have arranged this software to build an environment in which the AI agent can perform simulations in a loop within a lot of different scenarios, a lot of different conditions, and most important, learn from it. So this is the proprietary technology we have developed in Intemic, which contains a set of different unit operations like bioreactors, separation methods like centrifuges, and other chemical engineering unit operations, which then they are implemented in our technology that performs a lot of simulations, learns from them, and provides a pre-trained AI model where the user can get recommendations to design the flow sheet on an industrial scale. I know it's complex. It's complex to understand, but imagine if instead of having a software tool that you have to put all the information, perform all the calculation, and you have to do everything, imagine that you have a software tool that tells you recommendations in each stage of the design to optimize this design and optimize the OPEX, CAPEX, and the emissions and waste. And this is one example of process design we performed through our algorithm, in which you can see that new process design is based on long-term strategies. This means that it's very complex because every unit operations involved the next ones. So it's this complexity about designing these new processes on an industrial scale. And our mission is to give companies a tool which can help them evaluate new products from renewables. For example, biomass or waste or CO2, as I mentioned. So they can evaluate the production of new chemicals and, most important, evaluate the economic impact of this process and the life cycle analysis, which is one of the requirements to perform and continue with these projects in more TRLs. So for making a comparison, for you to understand how different is our product from benchmark products, we could imagine like different levels of automation or design decision support systems, in which you could have on a very low stage single calculations like Excel sheet or process simulators, where companies use it to make calculations. For example, calculate the volume of a needed reactor to achieve a given conversion, for example. Then the next step is performing a case study of these calculations, but in different conditions. So companies can evaluate, for example, different conversions obtained in a different range of reactor volumes and other variables. So you get like a complete matrix of experiments where you can get some conclusions about it. And the next step, which is what we are working on Intemic, some groups of research in University of Delft, they are also working on it, but it's very recent, is learning from that simulations to give recommendations. So it's like performing open exploration in different conditions, learning from that conditions and give the customer the recommendations. So this is a screenshot of our software platform, which is currently an MVP, a minimal valuable product, where you can see that we have to improve a bit the user experience and the design. But the core of the program is training a reinforcement learning model, which then can give these recommendations I was explaining in each step of the design. So then you can see a whole flow sheet recommendations with the information about this flow sheet, and just follow the recommendations that the software gives. So this was our product. The mission of industrial biotechnology is to make our daily products from renewables, and sometimes genetic engineering can be applied to perform this transformation using the power of biology. And we think that by using our tool, we give companies a very useful tool to estimate complex projects from very early stages or very low TRLs, which means that companies can have a very long-term vision of how much money could their process need, and then keep performing the enzyme optimization and evaluating different feedstocks and all this project methodology, but with the AI recommendations. One of the other things that we are doing in our platform is integrating a marketplace of waste and byproducts in which companies can use to simulate new processes. So, for example, can be agricultural waste and industrial byproducts in which the users can use it to automatically perform the process simulation. So I talked a lot about the product. I know it's complex. I hope you didn't get very bored, but I will talk a bit business models and how can you obtain benefits from scientific discovery and research. In our case, our customer pays to use the software. It's a software as a service. It means that the customer pays a monthly or annual license to use our tool. And we are also integrating this marketplace of waste providers, in which we think it can have a lot of impact in the future, because in a future without fossil fuels, companies will need to manufacture from waste. So this marketplace of waste providers, we think it will be very important. So we mainly charge this license to the customer. And one of the important things that we need to know as researchers or as scientists is how to sell to companies. Because one of the things we typically see and we typically get involved in our mind is B2B selling, B2C selling. It means selling to customer. And it's the typical selling about, I have a product, I sell it to you at this price, I make to you a discount, and I give this promotion. But this actually doesn't work with companies. Companies, they want products that work, that solve their problems, and they have a big confidence that this solution is going to solve their problems. So for me, I would say it's very different selling to customers like for example, selling an iPhone to a customer, which is money from him, and it's a more irrational decision, and selling products to companies, which there is a big implication for this company. Also, the amount of money will be much bigger for this, and the person in the company that you try to sell him your product or your research has to be very confident, and it must trust you to implement that in the company. Because if the company buys your solution and your solution don't solve problems, the employee from that company gets out of the company. So I would say it's important to give confidence to customers, and this can be by writing scientific articles to demonstrate your knowledge about the field you are talking, demonstrate that you understand the company's problems, also by making very smart questions about their problems, which makes them understand that you know a lot their problems and you know a lot how to solve their problems. And then you have to identify how big is their problem for that organization, because the final end of this spin, the net payoff, is going to be proportional on the company's problem. So if it's a big pain in the ass, if it's a big problem for the company, you can ask for a lot of money. But if it's a must have, or it's, sorry, if it's something that they are not very worried about, it's difficult to sell them. So at the end of the day, and now I'm concluding my presentation, I would say it's very important to be an expert on the field. So if you are a researcher, you have a lot of numbers to be a very good professional about your industry or your field, and communicate to companies that you are the one who can solve this problem. And then there are a lot of complicated things like building a team and motivate people to work with you. But you have to be the visionary and the problem solver. Then people come and help you. And for finalizing my presentation, some of the grants in the European Union we are trying to get, and I guess Deep Tech will have more helpings in fundings and government grants, because it's so complex to develop these deep tech applications, because it requires a lot of research, a lot of time to develop the product, and it's very difficult to start selling from the first day. So these grants and fundings are actually very needed to implement to your strategy and take your product to the market. So this was my presentation. I don't know if you have questions, but I will be happy to answer. Thank you very much.
Oh, yeah, thanks, Albert. Thanks for the talk. Yeah, that was really interesting. I can open up the chat now for any questions. If anyone wants to direct message me or post it straight in the chat. If not, I may start with my own question. Okay, so Albert, since you mentioned that you started Intemic because you didn't see any other similar companies in Spain. So since you started Intemic, have you seen any other research groups that do what you do or look quite interesting? And if not, what are the hurdles that people aren't really jumping on this?
Yes, in Spain, obviously I didn't found any company. Not only any company, but also I didn't found any research group on Spain. So I was like, I saw this potential and I started Intemic without knowing any other group or people working on it. But during the project, I discovered a group from the Delft University in Holland, which is led by Arthur. Arthur, and they are working on some interesting things, and they are writing papers about this. So for me, it was very. I was very happy to see that other groups are looking in a similar direction with similar implementations, but we are very few people in looking in this area of research.
All right. Oh, I've had a few people message the chat, so I'll just read it out for everyone's benefit. So someone messaged, thank you for your insights. Would you be able to share more about your entrepreneurship journey, especially the part where you mentioned you entered a very traditional field where protocols are difficult to change? What other pains did you have to go through to get your first B2B customer?
Yes. I have to say that it's very difficult to enter into the industry and for big companies or industrial companies to trust your solution. And one of the things that I personally think it helps is to have worked in the industry. For example, if you work as a chemical engineer, you see the problems of the day-to-day, and then you can imagine the solution for them. So it's very easy. Well, it's much easier if you have been inside the industry and then you create your own spin-off or company to solve that specific problems. But it's actually very difficult when you don't have a big name in the industry and you have to create your personal brand from scratch, and it's a lot of work preparing a lot of PowerPoint presentations to acceleration programs, to send it to investors. And one of the things that makes it very difficult is that not many investors, almost in Spain, not many investors invest in deep tech because they don't understand the core of the technology. So, and answering that question, sorry, what are the things did you have to go through your first B2B customer? I actually contacted a lot of companies, and the first customer, it was in a conference here in Spain. We exchanged some work. And I have to say that it's fun how it's better to create business in gala dinners and in familiar scenarios where you can talk with your customer more calm and understand better your customer than just sending LinkedIn emails, you know. So my first customer, I met him on a gala dinner, and they were actually looking for an AI solution to solve their manufacturing problem, and it was like the perfect match. We do AI for manufacturing. They were looking for that problem, so it went good. But actually, it's difficult for the company to be conscious that they are looking for that. So, yes.
I do have another question in the chat, but Zhen is raising your hand, so yeah, I'll let you go first, Zhen.
Okay, thanks very much, Robert, for your interesting talk. I agree that actually it's not easy to change the current landscape of chemical industry. I think there is at least 4 parties, like the government, the waste producer, and a chemical producer, and a company like Intemic. So based on your opinion, which party probably is the best to start with? To talk with the government will be easier, or talking to the waste owner will be easier?
I think what do you say? The government or the waste?
Yeah, the government. I think there is at least 3 parties we can talk with, like the government, the policymaker. They are regulating the industry, right? And also the chemical producer, like chemical plant.
Yeah.
And another one will be the waste producer. I mean, the waste producer could be one kind of your customer. So, I mean, which one will be more easier to persuade them to make the change? Based on your experience.
I think the change is so slow because society is now understanding the importance of circular economy, and all the people is getting more involved in these environmental activities. So then companies are also integrating this sustainability and circular methodologies to sell to people. So actually companies are interested in making recycled products and putting this bio-based or ecologic label in their products. So I would say the companies, the manufacturing companies, I think they would be interested in that new methodologies and circularity. I also think that the government is giving a lot of, is putting money to advance the research on these methodologies. In the case of Europe, there are Horizon Europe, which is funding for companies to research and innovate in biorefineries and all this circular. So I think it would be a mix within all the partners, and it's not trying to change the world with the startup. It just go with the innovation of the industry or society and offering your solutions. I don't know if it was.
Well, thanks.
Yeah.
So may I ask another technical questions? I'm not expert in aspirin, but just now you mentioned that actually the AI is trained based on the data generated by aspirin, right? Am I right?
What? Sorry, could you repeat?
Just now in your discussion, I think your AI model actually is trained on basis of the data generated by Aspen. Am I right?
We don't use Aspen. We use an open source simulator, which is called BioStim. which is very recent and is actually very good because the thermodynamics and everything, you have this calculation engine, which gives very similar results compared to Aspen, and everything is in Python. So it's very modular, and you can integrate this simulation into the AI system.
Okay, so if all the data can be generated by this software or Python package, whatever, so I just wondering how the AI helps to improve the procedure, how the AI model interact with these existing processing softwares.
Yes, I think maybe I can go. So here, this is a very basic representation, but here you have flowsheet simulations where you have a lot of information about the flowsheet. You have temperatures, you have compositions of all the streams, you have the unit operations. Well, there is a lot of information in the flowsheet. And AI looks into the all information and captures all the information to make decisions of which unit operation would be needed to add into the flowsheet. Okay, so from a specific flowsheet information, the AI can decide, okay, I will add a bioreactor, for example. And then it generates a lot of different flowsheets and learn about the final metrics of the flowsheet. How much money did this flowsheet cost? How much waste did this flowsheet generate? And then start again a flowsheet, understanding some patterns about the decision making.
Okay, cool. Now I understand. This is basically a reinforcement learning framework. So you keep optimizing the process. Okay, thanks a lot.
All right, I'll read out another question that someone wrote in the chat. How close are you to commercializing the reinforcement learning product for process design? This research is quite novel. Therefore, I am curious which hurdles you still see.
Yes, we have a beta version, which means that we have our algorithm working. We are evaluating a lot of different types of processes, and we have a list of companies or people that are trying out with our solution. And it's like a proof of concept, and it's a paid proof of concept, but it's cheaper than the commercial license, which we think we will get in finals of this year, January of 2023. But if there is people interested in this, we might give this beta test option. So you can write at the email, and we are happy to receive feedback from people, especially if they are researchers and people with a lot of knowledge that can give a very valuable feedback.
All right. That's just been another question, so I'll read that out. I think we might have this as the last question. It's about 4:52 now. So how do you ensure robustness of the AI process simulation, whether for design or existing processes? And who do you see as the customer for AI-based process design?
Yes, a good question. We are comparing now the AI-generated designs with benchmark designs to compare the economics and the environmental metrics. And most of the times, for different processes, we obtain better results than benchmark designs. thanks to AI optimization. The robustness of the design and the validity of this design can be evaluated because it's mass and energy balances. And these mass and energy balances, we don't use AI for this. This is important. We use mechanistic models, which are just mathematical models like Aspen Plus uses. So at the end of the day, the mass and energy balances of the unit operations, it's not AI predictions. It's calculations that we have the formula, and we also can provide in the white paper of the software. So it can be validated, all the mass and energy balances of the unit operations, and which calculations did the AI.
Right. All right. I hope that.
Sorry, I think I didn't answer the second.
Yeah, the second one. Who do you see as the customer for AI-based process design? Yeah.
Yeah. For the moment, we are working only with one company from France, which is a chemical engineering company called Processium, which works on the conceptual design of new processes. So they work for early stage projects for companies or startups, and they develop this flow sheet to evaluate the upscale of the production. So initially, we think these engineering companies would be the interested companies, the interested customers, but also we want manufacturing companies to be able to use this for evaluate how much money would cost new alternatives. So we're starting with that. Yeah.
All right, thank you. Thank you everyone for your really engaging questions. Yeah, this session, the Q&A went on for quite a little bit. I've added some helpful links into the chat for anyone who'd like to be notified of future talks. And Albert has also joined our LinkedIn group. So if anyone wants to reach out to Albert, his email, he supplied his email and he is also on LinkedIn. So please do reach out. With that, I think we can say thank you, Albert, very much for attending and for providing a really interesting discussion on your company.
Thank you to everyone who got involved in this, and thank you for watching.
Yeah.
Have a good day.
You too. Thank you, everyone. Have a good day. Bye.
Bye.